Try to remember your first birthday. You can't. Try to remember learning to walk. You can't do that either. You have no memory of the two most important years of your life. That's strange. That's actually one of the strangest things about being human, and the real answer is far stranger than babies just forget things. Because babies don't forget. Babies remember constantly. A 6-month-old recognizes your face. A 1-year-old remembers where the toy was hidden yesterday. Your brain, at that age, was already forming memories every single day. So where did they go? This gap has a name. Scientists call it infantile amnesia. It's not a flaw. It's not a bug in your development. It happens to every human being who has ever lived, in every culture, on every continent. And for over a century, nobody could fully explain why. Sigmund Freud was the first to give it a name, back in the early 1900s. He thought the memories were repressed, buried by the mind because early childhood was full of urges too uncomfortable to keep in view. It sounded compelling. It made for a good theory. It was also mostly wrong. The real explanation didn't come from theories about hidden desires. It came from watching the brain grow. Picture your brain as a construction site, not a finished building. A site, mid-build, scaffolding everywhere. Workers pouring concrete in some rooms while other rooms don't exist yet. In your first 2 years of life, one particular structure is under heavy construction. It's called the hippocampus, and the hippocampus is the part of your brain responsible for stitching moments into memories that last. Here's the key detail. The hippocampus isn't storing nothing during infancy. It's storing too much, too fast, and constantly rebuilding itself in the process. Neuroscientist Paul Franklin at the University of Toronto ran a series of studies on this exact question using mice. Young mice, it turns out, generate new brain cells in the hippocampus at an extremely high rate. This process is called neurogenesis. It sounds like a good thing. More brain cells, more capacity, right? But Franklin's research showed the opposite effect on memory. The flood of new neurons doesn't get added carefully alongside old ones. It shoulders its way in. It rewires existing connections. And in doing so, it appears to overwrite the very memory circuits that were just built. Think of it like a library where new books keep arriving so fast that the librarian has no time to shelve them properly. Instead, the new arrivals get shoved onto shelves where old books used to be, knocking them onto the floor, unread, unfindable. Your infant brain isn't failing to save memories. It's saving so many so quickly that it keeps erasing its own recent work to make room for the next wave. That's why an 18-month-old can remember something for a few weeks and then completely lose it. That's why toddlers can perform incredible feats of short-term recall and still, later, hold none of it as long-term memory. The system isn't broken, it's overloaded by its own growth. But neurogenesis is only half the story. The other half is language. Psychologist Catherine Nelson and later Carol Peterson at Memorial University of Newfoundland spent decades studying how children talk about their own past. What they found was that memories don't really become story-shaped until a child has enough language to narrate them. A 2-year-old experiences an event. A 4-year-old can tell you about an event. And it's the telling, the narrating, the placing of an experience into words and structure that seems to lock a memory into something retrievable years later. This means memory isn't just a recording device. It's closer to a story you keep rewriting, and you cannot rewrite a story you don't yet have words for. Peterson's research went further. She tracked children over years, asking them to recall specific early memories at different ages. What she found was almost eerie. The memories children could describe most vividly at age 4 had almost completely vanished by age 8, replaced by entirely different early memories. The content of your earliest memories isn't fixed. It's still being edited well into childhood, shifting, some fading, others suddenly sharpening, long after the actual events occurred. So which is it? Is it the flood of new neurons erasing old wiring? Or is it the absence of language to hold the memory in place? The honest answer, the one most memory researchers now accept, is both, tangled together, feeding each other. Your hippocampus is rebuilding itself while your language center is only beginning to switch on. Two unfinished systems trying to cooperate in the middle of the most memory-dense period of your entire life. Here's where it gets stranger still. Elaine Rees, a developmental psychologist in New Zealand, discovered something unexpected when she studied how parents talk with their toddlers about the past. Parents who used what she called elaborative conversation, asking open questions, adding detail, encouraging the child to add their own detail, had children who developed earlier and richer autobiographical memories. Parents who simply asked yes or no questions, without elaboration, had children whose early memories faded faster and formed later. In other words, part of your earliest memory wasn't built by your brain alone. It was built in conversation. It was built by someone else asking you, and then what happened? The people around you, quite literally, helped construct the scaffolding your memory needed in order to hold on to anything at all. This reframes the whole mystery. You're not missing your first 2 years of life because your brain failed you. You're missing them because your brain was too busy building the machinery memory would eventually run on. And that machinery needed two things working in tandem. It needed the hippocampus to slow its own frantic self-renovation. And it needed language given to you by other people to give your experiences a shape worth keeping. Most researchers place the boundary of infantile amnesia somewhere between 2 and 4 years old. Before that boundary, memories are formed, genuinely formed, and then dissolved by the very growth that was supposed to preserve them. After that boundary, the hippocampus stabilizes, neurogenesis slows, language catches up, and suddenly, memories start sticking the way they will for the rest of your life. Which raises an uncomfortable question. If your brain was doing all of this rebuilding without your permission, without your awareness, how much of what you consider you was shaped in a period you'll never be able to check? Because here's the part that should unsettle you a little. Everything happened before 4 years old. The way you attach to people, the way you respond to being startled, the baseline sense of whether the world feels safe or unpredictable. Developmental psychologists broadly agree that these patterns are laid down in the exact window you cannot remember. You are, in a very real sense, walking around today running on code written by a version of you that left no notes. You didn't lose those years. Your brain used them differently than it uses years now. It wasn't storing a photo album. It was pouring the foundation. And you don't ask a foundation to also serve as a photograph. It has one job, and it did that job, even while quietly discarding the specific memories built on top of it. So next time someone asks if you remember your first steps, your first word, the first time you saw snow, you can tell them the truth. You do remember. Not the moment. The result. Every fear you carry that you can't quite explain. Every place that feels instantly like home for no clear reason. Every person who reminds you of safety before you've even spoken to them. That's the memory. It was never erased. It just stopped looking like a memory and started looking like you. Try to remember your first birthday. You still can't. But maybe now you understand why that's not a loss. It's a receipt for something far more valuable that got built instead.